Okay, geometry students, in this video, we will continue our study of areas of polygons. Now, in the last lesson, I'm trying to think what we looked at. In the last lesson, we looked at perimeter and area of rectangles and squares. And so today we're going to move on and we're going to look at the area of parallelograms and triangles. So no perimeter today, just area, okay? Please, lesson 11.2, please include today's date if you would, please. Please include today's date, and here we go. Area of parallelograms and triangles. Lesson 11.2. And be sure to include today's date. Now, like the 11.1 video, I'm going to keep this video very short, and I want you to focus most of your attention on your homework. There are some really good, solid, awesome, challenging problems in your homework, and that is what is going to consume most of your time, okay? Not this video. I want you students to learn how to problem solve, reason, and work through problems on your homework on your own. And of course, use the help video if you have to. Now, with that in mind, here we go. Area of a parallelogram. Please copy this down. Here's the formula for the area of a parallelogram. Base times height. I'm going to go pretty fast, so if I go too fast, just pause the video. Area of a parallelogram is base times height. Now, in your notes, if you would please, go ahead and draw a parallelogram, okay? Now, the first thing I want to show you is this. The parallel sides are always the bases, alright? Now, when I say that, obviously all of the sides are parallel, okay? This side is parallel. This side is parallel to this side. And this side here is parallel to this side here, okay? And I get that, but the point I'm trying to make is, is that your base can be any side, just depending on how this thing is turned, okay? If this entire thing was turned like this, then your base would be this side here. So the base is your parallel side, and it's the one that's running across horizontally, okay? Now when they ask for the height, and every year I tell students this, they make the same mistake over and over and over. This is not the height. That is not the height, and neither is this. Okay, the height of a parallelogram is the line that is perpendicular to the base. So it goes from the top of the parallelogram down to the bottom. So that's perpendicular. In other words, it runs from base to base, parallel line to parallel line, and it has to be perpendicular. And of course, if it's perpendicular to one side, it'll be perpendicular to the other side because both of those bases are parallel. So that is the height right there. Got it? Now students, who in the class cannot take two numbers and multiply them together? Base times the height. It's really, really, really simple. So, if I gave you this problem here in your notes, please copy this down. If I gave you this parallelogram here, and I said the height of this parallelogram is 4, and the base of this parallelogram is 10, find the area. Well, the base is 4. The height is 4, the base is 10, so the area is simply 40 square units. I say units because we don't know if it's inches, yards, or feet, okay? So there we go. Now students, let's take this a step further, okay? What if I had, and you do not have to write this down if you don't want to, I'm not going to work the whole problem out, but I might give you a height like this and tell you that the segment from here to here is 3, and this segment right here is 5, and this segment from here to here is 8, from here to here. And what if I said find the area? Well, in order to find the area, you need what? Two things: the base and the height. We do know the base. The base would be 11. Now, I told you I'm not going to work this whole problem out, and I'm not going to. I'm just trying to get you to think these are the types of problems we're going to throw at you in your homework. So the entire base would be 11, correct? You can just sit there and listen if you want to, and just watch. So students, the only thing that we're missing is the height. Well, that can be found so easily. Do we not have a right triangle right here? Sure we do. Pythagorean's theorem. You know the hypotenuse. You know a leg. If you were to find the other leg right here, it would be 4. Try trust me. So now you know what the height is, and now you can find the area. So problems like that, and also much more difficult, will be in your homework. But from now on, anytime I ask you to find the area of a parallelogram, all that you have to know is this: base times height. Isn't that simple, guys? It really is. If you'll take the time to learn these formulas, which you will need to learn, you will be fine. Now, let me show you how we come up with this formula, okay? Would you please watch this carefully? Watch. If I were to take this piece right here, and watch, and cut it off right here. In fact, let me do that. Let me go down, over, and up. If I were to cut that piece off and slide it right over here, I have a rectangle. Okay? So that means this piece here now is totally gone. So what I have is, well, I did not mean to do that, that's for sure. But what you have is a rectangle. So really, when I said to do the height, that was like the width. And when I said to use the base, that's like the length. So you're taking length times width, which gives you the area of a rectangle. And a rectangle is the exact same area as a parallelogram. Okay? Exact same area, because you simply take this right here, right there. And, well, I've got some stuff there I've got to erase, but anyways, you get the point. So that's how this formula works, okay? If you cut this off right here, it fills in right over here. And your base is still 11, and your height would still be 4. So you have a rectangle that's 11 by 4, which is 44. So that's where we get that formula from, okay? Alright, moving on to the next formula. Moving on, area of a triangle. You should know this from middle school. 1/2 times base times height. 1/2 times base times height, or another way to teach it is you take your base times your height and then divide it by 2. It's the exact same thing. However you want to do it is fine, okay? Now, let's go ahead and take a look at this. Copy this triangle in your notes if you would, please, okay? Now let's start with this triangle here first. If I asked you to find the area of this triangle right here, you would have to know the height. Now the height is not this line right here. It is not this line right here. It is the line that is perpendicular to the base that goes from the top of the triangle down. So the height would have to be this line right here. Now I know the base does not come all the way out to here. I know that. But if it did, you would have a right angle here, okay? And by the way, when I say the base, if I told you that the length of the base from here to here was 10, that's what you would use. If this was 2 right here, you would not use 12, because 12 is not the base of the triangle. The base of the triangle is simply 10, okay? But the height sometimes has to be drawn on the outside of the triangle. Sometimes the height has to be drawn on the outside of the triangle. Do you see what I'm saying? And so then if I told you the height was also 10, we can very easily find the area of that triangle. Now take notes on this however you want to, okay? But 10 times 10 is 100, times 1/2 is 50. So the area of this triangle here would be 50 square units, okay? So in order to find the area of a triangle, you must know what the base is, and you must know what the height is, okay? And there we go. Now over here in this example, and please copy this triangle in your notes if you would. Again, if I'm going too fast, just have the supervising teacher pause the video. But here the height would be inside the triangle. So you start at the highest point of the triangle, and you draw a line that is completely perpendicular to the bottom side, or to the base, and that would be your height. Let's pretend your height here is 8, and let's pretend that your base is 9. Well, the area of this triangle would be 36 square units, because you would take 8 times 9, 72, and then divide that by 2, or multiply it by 1/2 either way, and you will get 36, okay? So that's how you use this formula. I hope you understand that. It's really, really simple to find the area of a triangle. Of course, you should know from middle school, area of a triangle is the space that is on the inside of a flat surface, okay? And so that would be the area of the triangle, 36. back and watch this, okay? You don't have to take notes on this. Go ahead and enclose this into a rectangle, okay? There we go. Now, if you were to drop this height down like this, trust me, this triangle right here would fit right here, and this triangle here, if you flipped it over, would fit right here. So don't you see what we have, guys? I told you the height here was what? 8. Well, wouldn't that be the exact same length as this out here? Sure it would, sure it would be. Did I not tell you the base was 9? Well, that would be the length. So if I took 8 times 9, that would give me 72. That's the area of the entire rectangle. But we're going to cut it in half because this triangle here is twice. This triangle here is twice. So if we get rid of this triangle and get rid of this triangle, that's half of the rectangle gone. That's why you take 8 times 9 and multiply it by 1/2 or divide it by 2. 1/2 times 8 times 9, which is 36. Now, I hope that makes sense. If not, I'm not going to test you on it. I'm just trying to show you where these formulas come from. Now, after all, geometry is about proving things and stuff like that. Now, over here, this could be a little different because you're going to draw. If you try to enclose a rectangle here, it's going to be a little weird, okay? Because there's really no triangle that can be drawn that's going to fit in here. So, in that case, whenever your height is on the outside of the triangle like this one was, I would like to prove to you where we got the formula by turning this around like this. Right there. Okay, now it's the same triangle, right? It's the exact same triangle. I didn't do anything different to it. So now go ahead and enclose your rectangle, or go ahead and enclose the triangle so that you have a rectangle. And then draw your height. And when you do that, this triangle here would flip over and be just like this triangle here. This triangle here would flip over and be just like this triangle here. Okay, there is a way to prove that, by the way. That this triangle here and this triangle here are congruent, and this triangle with 2 dots and this triangle with 2 dots is congruent. So once again, you take the width times the length, gives you the area of the whole rectangle. Then, because you have twice as many triangles, then multiply it by 1/2 or divide it by 2, and you're left over with the area of the triangle. Okay, just wanted to show that to you. Guys, that's it. I told you it'd be a short video. I hope this video's made sense. If you have any questions, don't hesitate to call or email.